This video covers section 5.4, dividing monomials, the quotient rule, and integer exponents. Objective 5, simplify exponential expressions using the laws of exponents. We have acquired a big long list of exponent properties. The laws of exponents, as we call them. The product rule, we add the exponents. The power rule, we multiply. The product to a power, we distribute the exponent. The quotient rule, we subtract the denominator's exponent from the numerators. Quotient to a power, both the numerator and denominator get the power. And the zero exponent rule, anything to the zero power is 1. And negative exponents. If it's a negative on the top, it goes to the bottom by changing the sign. And if it's on the bottom, it goes to the top by changing the sign. And the last one is when you have a fraction raised to a negative, it's the reciprocal of that fraction. Letter A, we multiply negative 4, a to the negative 3 times 5a. Negative 4 times 5 is negative 20. And a to the negative 3 times a to the first, those add. Negative 3 plus 1 is negative 2. So we get negative 20, and the a to the negative 2 goes to the bottom as a squared. Letter B. Just like monomial times monomial, we're going to multiply the two coefficients together, negative 2/5 multiplied by negative 15/2. M to the negative 2 is going to be multiplied by m, and n to the negative 1 by n to the 0. These 2's will cancel. These two negatives will cancel, and 5 goes into 15 3 times. M to the negative 2 times m to the first. Negative 2 plus 1 is negative 1. N to the negative 1 plus 0 is n to the negative 1, or you could just say n to the 0 is 1. Now, both those negative exponents, they go in the bottom as an m times n, leaving the 3 in the numerator because it's to a positive. Letter C. I like to simplify my fractions first. 4 goes into 16/4, and 4 goes into 12/3. Now I like to take all of my positive exponents and leave them right where they are. A to the negative 4th goes to the bottom as a to the 4th. B to the negative 1 on top goes down as a b to the 1st, and b to the negative 4 on the bottom goes b to the 4th. When they're on the same level, they're going to add. 1 plus 4 is 5. When they're on the different levels, top, bottom, they subtract. Bottom from the top, 4 minus 1 is 3. The opposite of b cubed over 3a to the 5th. This leads us to 3 practice problems for you to try. I encourage you to press pause on your video and come back when you're ready to check your answer. Now that you've had a chance to work these out, I'll work these out for you. We've got to get rid of these exponents on the outsides before we can multiply, so that's negative 3 squared, m to the negative 2 squared. 9 squared, m cubed squared. Negative 3 squared is 9. m to the negative 2 squared is m to the negative 4. 9 squared is 81. M cubed squared is m to the 6th. Nine times 81 is 729, and m to the negative 4 times m to the 6th. We can either put that m to the negative 4 in the bottom as an m to the 4th, or we can just add these together. Negative 4 plus 6 is 2. Letter B. 5 goes into 45, 9, and 5 goes into 35, 7. Now I move my negative exponents, keeping the positive ones right where they are. X to the negative 2 goes down in the denominator as an x squared. Y to the negative 2 goes down in the denominator as y squared. X to the negative 4 goes in the top as x to the 4th. If they're on the same level, the exponents add. If they're on the opposite levels, the exponents subtract. Denominator from numerator. 4 minus 2 is 2, giving us 9x squared over 7y cubed. Letter C. Let's distribute the negative 2 exponent to every piece, giving us 3 to the negative 2, y squared to the negative 2, and z to the negative 3 to the negative 2. We'll leave this 3 to the negative 2 for the time being, and then 2 times negative 2 is negative 4. Z to the negative 3 to the negative 2 is z to the 6. The negative exponents go down in the denominator, 3 squared, y to the 4th, and the z to the 6th stays right where it is. Three squared is 9, y to the 4th. Example 10. Let's go ahead and simplify everything inside the fraction before we cube. 2 goes into 4, 2, and 2 goes into 14, 7. The w to the first on the top will stay, and the w to the negative 1 on the bottom will go up as a w to the first. The z to the negative 3 on the top goes down as a z cubed. The w's are now on the same level, so they become 2 factors of w, or w squared. Now we cube everything inside. 2 cubed, w squared cubed, 7 cubed, and z cubed. Cubed. 2 cubed is 8. W squared cubed is w to the 6th. 7 cubed is 49 times 7. 343. And z to the 9. This leads us to your practice problem. I encourage you to press pause on your video and work this problem out and come back when you're ready to check your answer. Now that you've had a chance to work this out, I'll work this out for you. I like to simplify inside my fraction first before squaring everything. 2 goes into 6 3 times, and 2 goes into 16 8. My negative exponents, they move top to bottom, bottom to top. M to the negative 3 goes down to the bottom as an m cubed. N cubed stays up top, and m to the negative 1 goes up top as m to the first, and n to the negative 5 goes to the top as n to the fifth. We can still combine the n cubed and the n to the fifth. That's going to be 3 plus 5 is 8. But the m to the first over the m cubed, two ways to deal with this one. I like to think of it as 1m on top and 3 m's on the bottom and cancel them, and I'm left with an m squared on the bottom. The other way to do it is to use the rule, denominator's exponent from the numerators, and that's an m to the negative 2, which is 1 over m squared. Either way, the m squared's on the bottom. And you should see these kinds of things because when there's more m's on the bottom than the top, the remaining ones go to the bottom. Now we go ahead and square everything inside. I'll attach that negative to the 3 because we're squaring it. The n to the 8th squared, 8 squared, m squared squared. Negative 3 squared is 9. N to the 8th squared is n to the 16. 8 squared is 64. M squared squared is m to the 4th. This concludes the video for section 5.4. Dividing monomials, the quotient rule, and integer exponents. Objective 5, simplify exponential expressions using the laws of exponents.